In this video, we're going to evaluate rational expressions. So we're going to evaluate fractions, and the fractions will have variables in different parts of them. So we're just going to evaluate, and we're going to do some operations with them. So I have been given f of x is 8x, g of x is 1 over x, h of x is 4 over x minus 5. So let's put some things together here. So let's look at the operation of adding f of x and g of x. So f of x is 8x, and g of x is 1 over x. So I'm going to put those two together. And when I add those together, I see that I need a common denominator. So I need to find my least common denominator would be x. So in this case, I need to have something over x to be 8x. So I'm going to multiply the top and the bottom by x. So I get 8x squared on the top plus, this already has my denominator of x, so I don't need to do anything there. So I'm going to say 8x squared over x plus 1 over x is 8x squared plus 1 over x, and that would be my final answer. Now in this one, I want to multiply. So if you remember that f of x was 8x, and I can write that 8x over 1 if I want. G of x is 1 over x, and if I multiply those, I can cancel. X goes into x1, x goes into x1, so I'm left with 8 over 1, and we just normally write that as the whole number 8. Okay, so evaluating rational expressions is just taking a rational expression, some sort of expression with a variable in it, and substituting, not substituting, I'm going to add or subtract, do some operations with them. Okay. Now the second part of what we're going to do in this lesson is we're going to look at what's called complex fractions. Complex fractions are a fraction within a fraction. So in this case, I have 1/3 over 4/6. And I'm going to have to figure out how to simplify that. So if I need to simplify that, I need to realize that this top part is going to be divided by the bottom part. So really when I see that, it might be easier for me to say, well, that's 1/3 divided by 4 over 6. So it looks very complex the way it was given to us, but if I recognize that this fraction line also means divide by, I just take the top, 1/3, divided by the bottom, 4/6. Now I can just go ahead with my 5th grade fractions. I keep the first term, I multiply by the reciprocal, and now I can cancel things and multiply. So 3 goes into 3 once, 3 goes into 6 twice. So this becomes 2 over 4, which is also 1/2. So let's do another one. Again, we're just going to look at these and do a short division problem. So here's my main fraction line. So this becomes 5x to the 3rd divided by 6x squared over x plus 1. So what I'm going to do is say, well, that's 5x to the 3rd over 1 times the reciprocal. The reciprocal is x plus 1 over 6x squared. And now I can cancel some things out. I'm going to add parentheses here because over each fraction, top and bottom, we actually can add parentheses if that helps us. That reminds me to keep the x plus 1 together. So I have 6x squared and 5x to the 3rd, so my x squared, and this goes into here 5x times. And I can't see anything else that can be reduced, so 5x is what's left on the numerator times x plus 1, and what's left in the denominator is just 6 times 1, which is 6. Okay. Now my last example of a complex fraction is 6y over 5 over, or divided by, 2 over 4y. So let's write it a little easier. 6y over 5 divided by 2 over 4y. So remember our process. When we divide, we keep the first one, and we're going to multiply by the reciprocal of the second one. And then I can cancel and just multiply. So in this case, 2 goes into 2 once, 2 goes into 4 twice, and nothing else cancels. The 2 y's are both in the numerator, so I can't cancel them. So I have 6 times 2, which is 12, y times y, which is y squared, and 5 times 1, which is 5. So I've just simplified this complex fraction, which looks kind of worse than what it really is, into a division problem and then simplified it. Okay, so why don't we do some practice problems?